Hello, everybody. I forgot to mention something in my previous video. Let's do a quick review on this video, the one we did earlier. And the good stuff means we're going to react organolithiums or Grignards with ketones or aldehydes or epoxides. That's good. You make these new bonds. You can also do a Gilman, which I didn't write down that this is a Gilman. A Gilman can react not with an aldehyde or a ketone, but with an epoxide in the way that the Grignard or organolithium did here. And I totally forgot to mention this very useful reaction here. It's not a bad one, it's a good one. It's called coupling. This reaction here is called coupling. To bring together. A marriage is a form of coupling. You're joining a wife to a husband, right? And bringing together. So we brought together the organic piece off of the Gilman. It's a butyl, right? And there it is. And it's coupled to the ethyl group attached to a halogen. Okay? So I'm not going to make this a trivial little video. I think we're going to bring it all together, freestyle, and you're going to just do it on the bottom of your sheet there because you got room. And here it is. We're going to take it from the top. Let's do this guy and see if we can predict products. Just copy everything down here. Why not? SOCl2 and pyridine. And then I'm going to go 3 ways from here. I'm going to go with Mg, H2O. In this one, I'm going to go with lithium and that. And in this one, I'm going to go with first one, lithium, and 2. I'm going to hook it up with, what am I going to hook it up with? Copper iodide. And then I'm going to go, I'll flip over the page. And another box. And what else are they good for? Opening epoxides, huh? Some styrene. It's a road map. Road whip. And not the prettiest. Here we go. What do we want to hit this one with? And why not? Dead spot. Try to keep it on the page. There we go. So I'll pause. Pause share. Screen sharing is paused. Does that mean the video is still going? Does it? We're still talking and stuff. Okay, I learned that just now, I guess. So we're back. Resume share. Okay. So there's another chapter 10 reaction up there. Chapter 10 reaction. And we're going to put in red. Wow. What goes there instead of an OH? Cl. That's the equivalent of the PBr3 reaction. And we're going to make, in the magnesium reaction to the right, what's it going to look like when you're done? The red stays red. It's not attached to Cl anymore. It's attached to Mg, and the Cl got pushed out. That's the Grignard, isn't it? And this one here is the same carbons and a lithium. That's an organolithium. And first step in the next one, this one here, makes the organolithium that we drew here. That's the first step. And the second step makes it into the other G word. What's the other G word? Gilman. You don't get a point for writing Gilman. There's lots of ways to write the Gilman. You can do this way with the parentheses. To me, it's a lot of work. And then copper. What else is there? No, the iodine is gone. The Cl's gone from a long time ago. Lithium. Remember, 2 pluses for the 2 minuses. The carbons are each minus. The copper is still +1. So you need 2 single pluses. Another way to do it would be this. IBU 2 CuLi. Isn't that the same thing? Yeah. IBU is an acceptable short form for what group? Isobutyl. You guys knew this. Ibuprofen, right? IBU. All right. So however you want to do it. And hey, there's a halogen on there. I decided I want to make this a better example. Can you just edit this guy? One little edit, not a big deal. I want to have some geometry in that double bond. So I added a methyl on the left. Can you please add a methyl on the left here? I'm going to do it on the previous screen too, which is a blank screen, and come back. Oh, there we go. So there it is. The thing here is, what do we call this reaction again? It's not attacking an aldehyde, not attacking a ketone, not attacking an epoxy. So it's the other one. Okay, it's a form of redox, but we had another name for it on our previous video. No, it was the beginning of this video. Oh. Right there. Coupling. Yeah. And how did you predict the product of this coupling? The black piece from the Gilman is here. A new bond to the carbon that has the halogen. That's it. It's got to be one of the easiest predictions you can make. Just connect the 2 R groups. Okay, so here's the red R group. And it goes where what atom used to be. I will ask you again over here. The new R group ended up where what atom used to be on this group, this thing. What's on the blue here that's not on the blue here? Chlorine gets replaced by the carbon group. That's it. Learn to talk to yourself about reactions. So I guess the new bond's not in red here. The new bond's there. It's in green. And the cool thing about this is ethyl's there, this is there, this is there. So there's a reason it's called a coupling and not an SN2 reaction. It's not an SN2 reaction. If it was an SN2, that would be a backside attack, right? And my double bond would have the opposite geometry when I was finished. Here, the carbon group went exactly where the iodine was, in the same position. Yeah. Makes the prediction even easier, right? You copy the alkene, except for the iodine, right? And in the iodine's place, you put the new group. and you're done. And the next one, here's the new bond, IBU, new bond to a carbon. The left substituted carbon of this one right here is this one, right? That's the one. That's the one. You got attacked, left behind an O minus. O minus does what in step 2? Protonation, so O minus becomes OH. There you go. And, oh, I lost a box. There you go. So new group, new bond, carbon, carbon, O minus becomes OH. New bond to a carbon in a ring that had an O minus, it becomes OH. Don't forget the double bond there. That's a string mark. Big picture. There we go.